Intro. The M1 Abrams, a heavy-duty American tank, is like the big brother of armored vehicles. Designed for intense ground battles, it boasts cool features like a powerful engine that runs on different fuels, tough armor, and a computer system for precise targeting. The Abrams wasn't the first try, though. It evolved from an earlier project that didn't quite make the cut. Now, there are three main versions: the M1, M1A1, and M1A2, each better than the last in terms of firepower, protection, and technology. While there were plans to replace the Abrams, it's still going strong. They keep upgrading it with improved sights, tougher armor, and even bigger guns. Since 1980, it's been the main tank for the US Army, and other countries like Egypt, Saudi Arabia, and Australia use it too. This tank has seen its share of action, from the Gulf War to the more recent conflicts in Afghanistan and Iraq. It's a testament to its design that it continues to be a force to be reckoned with on the battlefield. History. In the 60s, the US and Germany teamed up to create a new tank that would outmatch the latest Soviet models. They envisioned a super tank with a powerful engine, advanced suspension for a smoother ride, and a massive gun. This project was called the MBT-70. Unfortunately, the MBT-70 became too complex and expensive. By 1969, the cost had skyrocketed, prompting the US Department of Defense to put the brakes on the project. Although attempts were made to simplify the design, it was ultimately scrapped in 1971 due to budget concerns. The end of the MBT-70 project was a disappointment, but it wasn't a complete failure. The lessons learned and technologies developed during this project paved the way for a new American tank, the M1 Abrams. Starting fresh. In 1972, the Army started a new project, called XM-815, to design a tank that could withstand any Soviet attack. They wanted it to be armed with a powerful 105mm gun and a smaller 20mm one. This new tank would also feature a special type of armor, called Burlington or Chobham, that was incredibly effective against certain types of enemy ammunition. This armor was so strong that it would make the tank quite heavy, but it was a necessary trade-off for increased protection. Learning from past mistakes, the Army was determined to keep the project within budget. They set a strict price limit for the tank and changed how they worked with companies. Instead of the government doing most of the design work, they asked companies to come up with their own designs and compete for the contract. In 1973, two major companies, Chrysler Defense and General Motors, submitted their proposals. Both designs had the required 105mm gun, but they differed in the engines they used. Chrysler chose a gas turbine engine, while GM opted for a diesel engine. This set the stage for a competition that would eventually lead to the birth of the M1 Abrams tank. In 1976, Chrysler and GM delivered their prototype tanks for testing. The results showed that GM's design had the upper hand, with better armor, aiming systems, and a more stable turret. However, both designs had problems with their engines. Chrysler's gas turbine engine guzzled way more fuel than expected, while GM's new diesel engine also had some issues. Despite the engine problems, by spring 1976, the Army was leaning towards GM's design. It was not only better overall but also slightly cheaper. It seemed like GM was going to win the contract, and the Army was ready to tell Congress about their decision. All they needed was the final approval from the Secretary of Defense. On July 20, 1976, Army officials met with higher-ups in the Department of Defense to discuss their decision to go with GM's tank design. To their surprise, they were told that the turbine engine was the way to go. The officials disagreed and presented their arguments to the Secretary of Defense, who then decided to delay the decision by 4 months. A few days later, GM was asked to come up with a new design that included a turbine engine. It became clear that the decision makers favored the turbine, which essentially handed the contract to Chrysler since they were the only ones with a gas turbine engine. Meanwhile, Germany sent over their Leopard 2 tank prototypes for testing. They had hoped their tank would be considered alongside the American designs, but the US Army wasn't keen on choosing a foreign tank unless it was clearly superior. Although the Leopard 2 met the requirements, it was deemed too expensive and was dropped from consideration in 1977. Despite the earlier preference for GM's design, Chrysler ultimately won the contract in November 1976. This wasn't just because of the turbine engine, though. Chrysler was more invested in tank development and had a track record with the successful M60 tank. GM, on the other hand, didn't rely much on military contracts for its income. Once Chrysler secured the deal, they focused on making the tank more affordable. They swapped out pricey parts for cheaper ones and negotiated better deals with their suppliers. They even found ways to save money on smaller components, like switching to a much less expensive hydraulic oil reservoir. They also offered a version with a diesel engine, just in case. These efforts paid off, and Chrysler lowered their original price by a significant amount. After losing out initially, GM revamped their design, incorporating a turbine engine and a turret that could handle either a 105mm or 120mm gun. However, the cost also went up significantly. Meanwhile, Chrysler impressed the decision-makers with their cost-cutting measures and ultimately won the development contract in November 1976. However, the road wasn't smooth from there. The initial pre-production models had several issues. At Aberdeen Proving Ground, the tanks kept throwing their tracks due to mud buildup, a problem that was partially solved by adding a scraper and adjusting the track tension. Additionally, the engine was sucking in debris because of gaps around the air filter, which needed fixing. At Fort Bliss, the tanks experienced transmission problems because soldiers were performing a maneuver called the bow tie that stressed the system. Chrysler had to add a device to prevent this maneuver. These initial setbacks were a reminder that even with the best design, building a new tank is a complex process with plenty of room for unexpected challenges. After clearing those initial hurdles, the M1 Abrams tank was finally approved for production in 1979. Chrysler built over 1,000 before the company was bought by General Dynamics Land Systems in 1982. By 1985, they had produced over 3,000 of these tanks, and they started rolling out onto the battlefield for the U.S. Army in 1980. Production took place at two main factories, one in Ohio and the other in Michigan. Even the U.S. Army's research lab got involved, helping to design better armor and ammo for the tank. The M1 came equipped with a powerful 105mm gun and cutting-edge Chobham armor, a special combination of metal and ceramic plates that offered superior protection. A slightly upgraded version, the IPM-1, was produced for a short time in 1984, featuring minor improvements to the armor and other components. This marked the beginning of the Abrams journey as a mainstay of armored warfare. While the initial M1 Abrams was fitted with a 105mm gun, there was already talk of switching to a bigger, 120mm German gun in the future. This was a topic of much discussion, as the 105mm gun was cheaper and easier to standardize with other NATO tanks. But, the potential advantages of a more powerful gun were hard to ignore. In 1978, the Army decided to go ahead with the 120mm gun on future versions of the tank. This led to the development of the M1A1, which also featured improved armor and protection against chemical, biological, and nuclear threats. By 1992, they had produced around 5,000 of these upgraded tanks. The M1 and M1A1 combined totaled about 9,000 tanks, each costing roughly $4.3 million. However, there was some criticism about the tank's cost and fuel efficiency compared to other similar tanks. Despite this, the Abrams quickly became a key part of the U.S. military, participating in training exercises alongside older M60A3 tanks in Europe. In preparation for the Gulf War, the Abrams was further upgraded with better firepower and protection against chemical and biological weapons. Gulf War. The Abrams tank finally got its chance to prove itself in combat during the 1991 Gulf War. The M1A1 version, armed with a more powerful gun and upgraded armor, was deployed alongside older models. It quickly became clear that the Abrams was superior to the Iraqi tanks, outmatching them in range and firepower. The Abrams could hit targets from much farther away than the Iraqi tanks, giving them a major advantage. They could destroy enemy tanks before the enemy could even get a shot off. In fact, very few Abrams tanks were hit by enemy fire, and none were destroyed by it. This was partly due to the Abrams' advanced armor, which even withstood some friendly fire incidents. However, the war did reveal some weaknesses in the Abrams side and rear armor, which were penetrated in a few instances. These lessons led to improvements in the tank's aiming systems and fire control. Overall, the Abrams' performance in the Gulf War solidified its reputation as a formidable fighting machine. Upgrades. The M1A2 was an even more advanced version of the M1A1. It came with a separate thermal viewer for the commander, a new weapon station, better navigation tools, and a fully connected digital system. These upgrades gave the M1A2 a major boost in its targeting and firing capabilities. They didn't stop there, though. The M1A2 System Enhancement Package, SEP, added digital maps, a communication system for commanders, and better cooling to handle the extra heat from all the new computers. This enhanced version even served as the base for the M104 Wolverine, a heavy-duty bridge-laying vehicle. The M1A2 SEP2 was an even further upgrade, with remote-controlled weapons, color displays, improved interfaces, a new operating system, stronger armor, and a more durable transmission. In addition to these upgrades, all versions of the Abrams received depleted uranium armor for extra protection. Other improvements included a complete overhaul for older models, digital enhancements, and efforts to standardize parts between the Army and Marine Corps versions. The focus has always been on making the Abrams more survivable, lethal, and well protected. Iraq War. During the 2003 Iraq War, M1A1 tanks saw further action when U.S. forces invaded the country and removed Saddam Hussein from power in Operation Iraqi Freedom. One notable achievement was a close-quarters battle near Mahmoudiyah, just 18 miles south of Baghdad, where M1A1s destroyed 7 T-72 tanks without any losses on the American side. The Iraqi tank crews were poorly trained and hadn't fired live rounds in the previous year due to sanctions, resulting in their failure to hit the Abrams tanks even at point-blank range. Learning from the Gulf War, the U.S. equipped the Abrams and other combat vehicles with combat identification panels to minimize friendly fire incidents. In some cases, immobilized or damaged Abrams tanks were destroyed by friendly forces to prevent enemy capture. During the invasion, Iraqi infantrymen managed to disable several Abrams tanks in ambushes by targeting the tracks, rear, and top with short-range anti-tank rockets. Other tanks were put out of action by engine fires caused by small arms fire igniting external fuel stores, which then spilled into the engine compartment. By March 2005, enemy attacks had forced around 80 Abrams tanks out of action, with 63 shipped back to the U.S. for repairs and 17 damaged beyond repair. To address vulnerabilities exposed during urban combat, some M1 Abrams tanks were fitted with the Tank Urban Survival Kit, TUSK, modifications, including armor upgrades and a gun shield, enhancing their protection and survival in urban environments. Reports in May 2008 indicated that an M1 tank had been damaged by insurgent fire using a Soviet-made RPG-29 Vampir with a tandem charge heat warhead capable of penetrating explosive reactive armor, ERA, and composite armor. The U.S. considered the RPG-29 a significant threat to armored vehicles and prevented the newly formed Iraqi Army from purchasing it, fearing it might end up in the hands of insurgents. Iraqi Army service. The United States provided Iraq with 140 refurbished M1A1 Abrams tanks between 2010 and 2012. These tanks saw action in mid-2014 when ISIL launched an offensive in northern Iraq. During the 3-month campaign, about a third of the Iraqi Army's M1 tanks were either damaged, destroyed, or captured by ISIL forces. By the end of 2014, only around 40 operational Abrams tanks remained in the Iraqi Army's possession. In response, the U.S. Department of State approved the sale of an additional 175 Abrams tanks to Iraq in December 2014. There were reports of Iranian-backed Iraqi Shiite Kataib Hezbollah brigades, operating M1 Abrams tanks, which were shown being transported by trucks to participate in the Battle of Mosul. It remains unclear whether these tanks were captured from ISIL, seized from the Iraqi military, or handed over willingly. One particular Iraqi-operated Abrams tank gained notoriety and the nickname the Beast after it became the only functional tank during the recapture of the town of Hit in April 2016, successfully destroying enemy fighting positions and emplacements. In October 2017, the Iraqi Security Forces and the Popular Mobilization Forces, also known as Al-Hashd al-Shabi, used Abrams tanks in assaults against the Kurdistan Regional Government Peshmerga in the town of Altun Kupri, also called Pert. Kurdish commanders claimed that at least one Abrams tank was destroyed by the Peshmerga during these clashes. War in Afghanistan. Canada and Denmark sent specially adapted Leopard 1 and 2 main battle tanks to southwestern Afghanistan, where the terrain is relatively flat and dry. In response to a request from Regional Command Southwest in late 2010, the U.S. Marine Corps sent a small group of 14 M1A1 Abrams tanks to southern Afghanistan. These tanks, from Delta Company, 1st Tank Battalion, 1st Marine Division, Forward, were deployed to support military operations in Helmand and Kandahar provinces. The modifications made to the Leopard and Abrams tanks allowed them to function effectively in the challenging environment of southwestern Afghanistan. 2015 Yemen Civil War. During the Yemeni Civil War in 2015, Saudi Arabia deployed M1A2 Abrams tanks against Houthi rebel forces. The tanks played a significant role in the conflict, engaging in combat operations throughout the region. In August 2016, the United States approved a deal to sell up to 153 additional Abrams tanks to Saudi Arabia. Notably, this deal included 20 battle damage replacements, indicating that a number of Saudi Arabian Abrams tanks may have been destroyed or heavily damaged during the ongoing fighting in Yemen. The inclusion of these replacement tanks suggests the intensity of the conflict and the challenges faced by armored units operating in the Yemeni theater. Russo-Ukrainian War. In January 2023, U.S. President Joe Biden announced the decision to send 31 M1 Abrams tanks to Ukraine to bolster their defense capabilities and help achieve strategic objectives, emphasizing that this move was not an offensive threat to Russia. The transfer of these tanks was approved as part of a larger support package. Initially, Pentagon spokesperson Sabrina Singh clarified that the tanks would be the M1A2 variant, but due to their unavailability in U.S. stocks, they would need to be purchased through the Ukraine Security Assistance Initiative, USAI, which could take up to 2 years for manufacturing and delivery. However, in March 2023, the Pentagon changed course, opting to refurbish older M1A1 variants from Army stocks to expedite delivery by the fall and avoid disrupting deliveries of new M1A2s to U.S. allies. Ukrainian President Volodymyr Zelensky announced the arrival of the first batch of M1 Abrams tanks in September 2023, with Politico reporting the number to be 10. These tanks were former U.S. Marine Corps vehicles, and more Abrams were expected to arrive in the coming months. In November 2023, the first images of the M1A1 in Ukrainian service appeared online, showing a tank near Kupiansk. Unfortunately, on February 26, 2024, an M1A1 was reported lost in Ukraine, with evidence suggesting that its ammunition had cooked off. It remains unknown if Ukrainian or Russian forces were able to recover the tank. Reports indicate that this M1A1 was destroyed by a Russian FPV Piranha 10 quadrone capable of delivering an RPG-7 warhead. As of April 2024, Ukraine has lost 5 out of the 31 Abrams tanks during their 2 months of service with the 47th Mechanized Brigade. U.S. defense officials stated that the tanks were withdrawn due to the challenging battlefield conditions, including muddy ground hindering maneuverability and the Russian use of hunter-killer drones making it difficult to operate the tanks effectively. The tanks supplied to Ukraine were older, export versions with classified U.S. armor removed before being sent to prevent or reduce the exploitation of technology if captured by Russian forces. Proposed production shutdown. After the U.S. Army ended serial production of the M1 Abrams in 1995, exports continued until 2000. The Army planned to suspend operations at the Joint Systems Manufacturing Center, JSMC, in Lima from 2013 to 2016 to save over $1 billion, with plans to restart in 2017 for upgrading existing tanks. However, General Dynamics Land Systems, GDLS, the factory operator, opposed this move, arguing that it would increase long-term costs and reduce flexibility. They estimated that closing the plant would cost $380 million, while restarting production would cost $1.3 billion. By August 2013, Congress had allocated $181 million for parts and upgrades to mitigate industrial base risks and sustain production capability. Critics accused Congress and General Dynamics of forcing the Army to buy unnecessary tanks. GDLS asserted that a 4-year shutdown would cost $1.10 to $1.6 billion to reopen the line, depending on various factors. They argued that the move was to upgrade Army National Guard units, maintain a pure fleet, and sustain production of irreplaceable subcomponents, warning that a prolonged shutdown could cause suppliers to lose their ability to produce them. Foreign tank sales were not guaranteed to keep production lines open, and there was still a risk of production gaps even with extended production through 2015. In December 2014, Congress allocated an additional $120 million for Abrams upgrades against the Army's wishes. By late 2016, tank production and refurbishment had fallen to 1 per month, with fewer than 100 workers on site. However, in 2017, the Trump administration ordered an increase in military production, including Abrams production and employment. In 2018, it was reported that the Army had ordered 135 tanks rebuilt to new standards, with employment rising to over 500 workers and expected to reach 1,000. Future plans. During the 1980s and 1990s, the U.S. military explored several options to succeed or supplement the M1 Abrams tank. The Block 3 main battle tank from the Armored Systems Modernization (ASM) program was expected to replace the Abrams in the 1990s, featuring an unmanned turret with a 140mm main gun and improved protection. However, the end of the Cold War led to the program's cancellation. The tracked M8 armored gun system was considered as a supplement for the Abrams in low-intensity conflicts, but despite prototype development, the program was cancelled. The 8-wheeled M1128 mobile gun system was designed for a similar purpose and has been introduced into service with Stryker brigades. The Future Combat Systems XM1202 mounted combat system was another potential replacement for the Abrams, but funding for the program was cancelled in 2010. Engineering Change Proposal 1, ECP-1, is a two-part upgrade process for the Abrams, with ECP-1A focusing on space, weight, power improvements, and active protection against improvised explosive devices, and ECP-1B potentially including sensor upgrades and multi-purpose round capabilities. As of 2021, the Army expected the remaining M1A2 tanks to serve beyond 2050, while planning to divest its M1A1SA variant starting in fiscal year 2025. The Marine Corps, under its Force Design 2030 restructuring plan, deactivated all tank battalions and transferred their M1A1 tanks to the Army by the end of 2021. The U.S. Army is currently evaluating a replacement for the M1 Abrams as part of the Next Generation Combat Vehicle (NGCV) program, known as the Decisive Lethality Platform (DLP). In September 2023, the Army announced the cancellation of the planned M1A2 SEP-4 variant, redirecting resources into a new variant named M1E3. Design. Camouflage has been an important aspect of the M1 Abrams tank's visual concealment throughout its service history. Early XM-1 pilot vehicles and LRIP tanks were painted with the Mobility Equipment Research and Design Command (MERDC) 4-color paint scheme. In 1983, the factory-applied forest green paint was replaced by Europe 1, a 3-color pattern consisting of green 383, brown 383, and black, coinciding with the adoption of chemical agent-resistant coating (CARC). During the Iraq War, U.S. Army Abrams tanks were painted in CARC Tan 686A. However, with the increasing importance of American operations in Europe, the Army began transitioning most of its vehicles to CARC Green 383 around 2017. M1A1S originally featured a NATO 3-color camouflage scheme of black/med green/dark brown CARC paint, which is still applied during rebuilds. Tanks deployed to Operation Desert Storm were hastily painted Desert Tan, with some later repainted to their authorized paint scheme. M1A2S built for Middle Eastern countries were painted Desert Tan. Replacement parts are painted olive green, sometimes resulting in vehicles with a mix of green and desert tan parts. Australian M1A1S are camouflaged in OSCAM, a scheme consisting of black, olive drab, and brown. In terms of concealment, the Abrams turret is equipped with two 6-barreled M250 smoke grenade launchers, 8-barreled version for USMC M1A1S, one on each side. When deployed, the grenades airburst, creating a thick smoke that obscures both visual and thermal imaging. The engine also features a vehicle engine exhaust smoke system, VES, triggered by the driver, which sprays fuel into the hot turbine exhaust to create thick smoke. However, the U.S. Army discontinued this system in the 1990s after switching to JP-8 jet fuel due to the risk of fire. The M1 Abrams tank boasts an impressive armor system, often referred to as special armor by the U.S. Army. This composite armor is thickest at the front of the hull, measuring up to 2 feet, 0.61 meters, at its most robust point. The hull's front is the only part, aside from the side skirts on the front half, to feature this composite protection. The Abrams turret also incorporates composite armor on both its front and sides, providing enhanced protection for the crew. Compared to previous tank models, the Abrams has significantly thicker armor. This isn't because the Chobham armor is weak, in fact, it outperforms traditional armor in defending against shaped charges and kinetic projectiles. However, Chobham armor is specifically designed to counter shaped charge projectiles, which were a relatively new threat on the battlefield, particularly in the form of anti-tank guided missiles. Without a groundbreaking advancement in armor materials to neutralize shaped charges, earlier tank designers found it impractical to add the massive amounts of conventional armor needed to defeat these weapons. While the precise makeup of the Abrams composite armor is a closely guarded secret, a general understanding of its function can be gathered from publicly available information. It features ceramic blocks embedded in resin, sandwiched between layers of conventional armor. The ceramic serves as a non-explosive reactive armor, NERA, disrupting shaped charges. Upon impact, the NERA plates shatter, interfering with the shaped charges penetrating jets or eroding kinetic rounds. Military historian Stephen Zaloga estimates the frontal armor of the base M1 Abrams model to be equivalent to 350 mm against armor-piercing fin-stabilized discarding sabot, APSTs, rounds and 700 mm against high-explosive anti-tank, HEAT, warheads, according to his book M1 Abrams Main Battle Tank 1982-1992, 1993. In M1 Abrams vs T-72 Ural, 2009, he cites Soviet estimates of 470 mm against APSTs and 650 mm against HEAT for the base Abrams, and 600 mm against APSTs and 700 mm against HEAT for the M1A1. To enhance protection against kinetic energy rounds, a new special armor incorporating depleted uranium, DU, was introduced into M1A1 production in October 1988. This upgrade added significant weight to the tank, as depleted uranium is 1.7 times denser than lead. The DU is used in the backing plate of the turret armor arrays. The first M1A1 tanks to receive this upgrade were those stationed in Germany. U.S.-based tank battalions participating in Operation Desert Storm underwent an emergency program to upgrade their tanks with depleted uranium armor just before the campaign began. All M1A2 tanks and all M1A1 tanks in active service have since been upgraded to this standard, with the upgraded M1A1 variant designated as the M1A1 HA. HA stands for heavy armor. The M1A1 AIM, M1A2 SEP, and all later versions of the Abrams tank are equipped with depleted uranium armor. Each model since the M1A1 has featured different generations of depleted uranium protection. The M1A1 HA uses first-generation armor, the M1A2 and M1A1HC have second-generation depleted uranium, and the M1A2 SEP variants boast third-generation depleted uranium armor with a graphite coating. This dense material is typically applied to the turret cheeks and sides, serving as a backing plate for the composite armor. Interestingly, at least 5 M1 Abrams tanks with depleted uranium hulls were produced and displayed at U.S. Army armor schools as of 2006. According to military historian Stephen Zaloga, the M1A1 HA's frontal armor is estimated to provide protection equivalent to 600 mm against armor-piercing fin-stabilized discarding sabot, APSTs, rounds and 1,300 mm against high-explosive anti-tank, HEAT, warheads, nearly doubling the original Abrams protection. In another book, he presents different estimates for the M1A1 HA, 600 mm versus APSTs and 700 mm versus heat for the front hull, and 800 mm versus APSTs and 1,300 mm versus heat for the turret's front. The M1A2 SEP's armor is even more impressive, with estimates suggesting frontal turret protection of 940 to 960 mm against APSTs and 1,320 to 1,620 mm against heat, glassy protection of 560 to 590 mm against APSTs and 510 to 1,050 mm against heat, and lower front hull protection of 580 to 650 mm against APSTs and 800 to 970 mm against heat. The latest M1A2 SEP3 further increases the line-of-sight thickness of the turret and hull front armor, although the exact protection levels resulting from this upgrade are not publicly known. In 1998, a program was initiated to improve the M1A2's turret side armor, aiming to better defend against more advanced rocket-propelled grenades than the RPG-7. Between 2001 and 2009, these upgrade kits were installed on approximately 325 older M1A2 tanks and included in new production vehicles. When necessary, the Abrams can also be outfitted with explosive reactive armor over the track skirts, such as the Tank Urban Survival Kit, and slat armor over the tank's rear and fuel cells to protect against anti-tank guided missiles, ATGMs. The original 105mm M1 Abrams does not feature spall liners, although 3 105mm rounds on the turret basket floor are protected by spall covers in this tank variant. The M1 Abrams is equipped with advanced damage control systems to protect the crew and the tank itself. In the event of a fire in the crew compartment, an automatic halon firefighting system is activated to quickly extinguish the flames. While halon gas can be dangerous to the crew at high concentrations, the 7% concentration used in the tank is much less toxic than the products released by a fire in the crew compartment. Additionally, using CO2 to suppress fires would be lethal to the crew. For fires in the engine compartment, a separate firefighting system is engaged by pulling a T-handle located on the left side of the hull. The crew compartment also contains small, portable fire extinguishers for immediate use. To minimize the risk of the tank's ammunition exploding if the vehicle is damaged, the fuel and ammunition are stored in armored compartments designed with blowout panels. The main gun's ammunition is kept in the rear section of the turret, protected by blast doors that open sideways only when a round needs to be loaded for firing, and then automatically close. As an added safety measure, tank operation doctrine requires that the ammunition door must be closed before the main gun is armed. These damage control features are essential in ensuring the safety of the crew and the tank's survivability in combat situations. The M1 Abrams tank, starting with the M1A1 variant, incorporates a comprehensive nuclear, biological, and chemical, NBC, protection system. This system is designed to safeguard the crew in the event of an NBC attack, allowing them to operate effectively in contaminated environments. The primary component of this protection is the turret overpressure system, which creates a positive pressure inside the turret, preventing the infiltration of harmful agents. This system eliminates the need for the crew to wear full NBC suits while inside the tank, as was required in earlier models. However, as a backup measure, NBC masks are still carried on board, and crews regularly train while wearing them. This ensures that they remain proficient and combat effective even if the primary NBC protection system fails or if they need to exit the tank in a contaminated area. By incorporating these advanced NBC protection features, the M1 Abrams provides its crew with a safe and secure environment, enabling them to focus on their mission even in the face of unconventional threats. The Tank Urban Survival Kit, TUSK, is a set of enhancements designed to improve the M1 Abrams tank's effectiveness in urban combat situations. Historically, tanks have struggled in close-quarters urban environments, where attacks can come from any direction, and enemies can easily target weak points in the tank's armor or gain a height advantage to strike the top armor. To address these vulnerabilities, the Tusk package includes several armor upgrades, such as reactive armor tiles on the tank's sides and slat armor on the rear. These additions help protect the tank from rocket-propelled grenades and shaped charge warheads. The Abrams Reactive Armor Tile, ARAT, system comes in two versions: ARAT-I, which adds 32 XM19 reactive armor boxes to the tank's sides, and ARAT-II, which mounts rounded XM32 reactive armor tiles over the XM19 tiles. The Tusk also enhances the tank's offensive capabilities. A transparent armor gun shield and thermal sight system are added to the loader's top-mounted M240B 7.62mm machine gun, improving accuracy and protection. The tank commander's 12.7mm, .50 in caliber machine gun is replaced with a Kongsberg Gruppen remote weapon turret, allowing the commander to operate the weapon without exposing themselves to enemy fire. An exterior telephone is also installed, enabling supporting infantry to communicate directly with the tank commander. In August 2006, General Dynamics Land Systems received a U.S. Army order for 505 Tusk kits, valued at $45 million, to support M1 Abrams tanks operating in Iraq. The company was expected to complete deliveries by April 2009. Separately, General Dynamics Armament and Technical Products was awarded a $30 million contract to produce reactive armor kits for M1A2S. The reactive armor tiles are produced at the company's facility in McHenry, Mississippi. In December 2006, the U.S. Army further enhanced the Tusk system by adding counter-improvised explosive device features to the M1A1 and M1A2 models, awarding GDLS an $11.3 million contract as part of the larger $59 million package. Additionally, GDLS received an order for loader's thermal weapon sights, accounting for approximately 40% of a $48 million order, as part of the Tusk system improvements for both the M1A1 and M1A2 Abrams tanks. The M1 Abrams tank has been equipped with various active protection systems to enhance its survivability against anti-tank missiles and rockets. Some U.S. Marine Corps Abrams tanks feature the IN/VLQ-6 Missile Countermeasure Device, MCD, a soft-kill active protection system designed to disrupt the guidance systems of semi-active control line of sight, SACLOs, wire and radio-guided anti-tank missiles, as well as infrared homing missiles. Although the MCD was not ready in time for the Gulf War, it works by emitting a powerful, concentrated infrared signal that confuses the infrared homing seeker of an anti-tank guided missile, ATGM, redirecting it away from the tank. However, the drawback is that the ATGM is not destroyed and may still detonate elsewhere. During the Iraq War, the U.S. Marine Corps equipped their M1A1S with an VLQ-8A electro-optical jammers for additional protection. In 2016, the U.S. Army and Marine Corps began evaluating the Israeli Trophy Active Protection System to defend their Abrams tanks against modern RPG and ATGM threats. The Trophy system works by either jamming ATGMs or firing small projectiles to deflect incoming threats. The Army planned to deploy a brigade of more than 80 Trophy-equipped tanks to Europe in 2020, with the goal of upgrading up to 261 Abrams tanks with the system, sufficient for 4 brigades. In June 2018, the Army awarded a $193 million contract to Leonardo DRS, the U.S. partner of Trophy's designer Rafael, to deliver the system in support of the M1 Abrams' immediate operational requirements. By July 2020, U.S. Army M1A2 SEP V2 Abrams tanks fitted with Trophy systems were deployed to Germany. Deliveries of the Trophy system to equip 4 tank brigades were completed in January 2021, significantly enhancing the protection and survivability of the Abrams tank on the modern battlefield. Armament. The original M1 and IPM-1 Abrams tanks were armed with the M68A1 105mm rifled tank gun, which was capable of firing various types of ammunition, including armor-piercing fin-stabilized discarding sabot, APSTs, high explosive anti-tank, HEAT, high explosive, white phosphorus, and an anti-personnel round containing multiple flechets. The M68A1 gun featured a license-made tube based on the British Royal Ordnance L7 gun, combined with components from the US T254E2 prototype gun, such as the vertical sliding breech block. Although the 105mm gun was effective, the US Army envisioned a weapon with a longer range and increased lethality to counter advancements in armor technology. To achieve this goal, a larger projectile diameter was necessary. The M1 and IPM-1 tanks could carry a total of 55 rounds of 105mm ammunition, with 44 rounds stored in the turret's blowout compartment and the remaining rounds in hull stowage. One unique characteristic of the M1 variant was the accumulation of empty cartridge cases on the turret floor after firing. As the cartridges were non-combustible, they required time to cool down before being ejected out of the tank's hatch by the loader. The M1A1 and M1A2 Abrams tanks are equipped with the M256 120mm smoothbore gun, which was designed by Rheinmetall AG of Germany and is manufactured under license in the United States by Watervliet Arsenal in New York. The M256 is an enhanced version of the Rheinmetall 120mm length/44 gun used on the German Leopard 2 tanks up to the Leopard 2A5 variant. The main difference between the two guns lies in the barrel thickness and chamber pressure. The Leopard 2A6 later replaced the L/44 barrel with a longer L/55 version. Due to the increased caliber of the M256, the Abrams can only store 40 or 42 rounds, depending on whether it is an A1 or A2 model. The M256 gun has an elevation range of -9 to +20 degrees, allowing the tank to engage targets at various angles and heights. The gun uses ammunition with combustible cartridge cases made from nitrocellulose, which are safer against premature ignition and flarebacks compared to earlier combustible cartridge rounds, although they are not entirely accident-proof. The Abrams primary armor-piercing fin-stabilized discarding sabot (APSTS) round is the depleted uranium M829, which has been produced in 4 variants. The M829A1, nicknamed the Silver Bullet, was widely used during the Gulf War and proved highly effective against Iraqi armored vehicles, such as the T-72 tank. The M829A2 APSTS round was specifically developed as an immediate solution to counter the improved protection of Russian T-72, T-80U, or T-90 main battle tanks equipped with Contact 5 explosive reactive armor, ERA. In 2002, the M829A3 round was introduced to enhance the Abrams' effectiveness against tanks equipped with next-generation explosive reactive armor, ERA. The development of the M829 series continues, with the M829A4 currently entering production, incorporating advanced features such as data link capability. Apart from APSTS rounds, the Abrams also fires high-explosive anti-tank, HEAT, shaped charge rounds, such as the M830. The latest version, the M830A1, features a sophisticated multi-mode electronic sensing fuse and increased fragmentation, making it effective against armored vehicles, personnel, and low-flying aircraft. The Abrams uses a manual loader who also assists with maintenance, observation post/listening post, op/LP, operations, and other tasks. The M1028 120mm anti-personnel canister cartridge was introduced early for use in the aftermath of the 2003 invasion of Iraq. It contains 1,098 tungsten balls that spread from the muzzle, creating a shotgun effect lethal up to 600 meters. The canister round is highly effective in clearing enemy dismounts, breaking up ambushes in urban areas, stopping infantry attacks, and supporting friendly infantry assaults. It can also breach cinder block walls and create man-sized holes in reinforced concrete walls at distances up to 75 meters. The M908 obstacle reduction round, a modified M830A1 with a steel nose, is designed to destroy obstacles and barriers by penetrating the obstacle before detonating. From 2002 to 2003, the U.S. Army Research Laboratory, ARL, conducted a thermal analysis of the M256 to evaluate the potential of using a hybrid barrel system for multiple weapon systems. The study concluded that mesh density affects the accuracy of the M256, and specific densities would be needed for each weapon system. As of 2013, the Army was developing the M1147 Advanced Multipurpose (AMP) round to replace the M830/M830A1, M1028, and M908. The AMP round has point detonation, delay, and airburst modes, simplifying logistics by performing the job of 4 different rounds. It is designed to be effective against various targets, including bunkers, infantry, light armor, and obstacles. However, as of 2024, the AMP round has not yet entered full-rate production. The XM1111 Mid-Range Munition Chemical Energy, MRMCE, a guided munition using a dual-mode seeker with imaging infrared and semi-active laser guidance, was also in development. Despite being selected over the competing MRMK, the mid-range munition program was cancelled in 2010 along with future combat systems. The Abrams tank is equipped with 3 standard machine guns and has the option for a 4th. 1A. 50 calories. 12.7mm, M2 HB machine gun is mounted in front of the commander's hatch. On the M1 and M1A1 models, this gun is part of the commander's weapons station, allowing it to be aimed and fired from inside the tank. The standard combat loadout for the M1A1 includes a 100-round ammunition box at the weapon and an additional 900 rounds stored in the tank. The M1A2 variant features a flex mount that requires the tank commander to expose their upper torso to fire the weapon, which was found to be unsafe in urban environments in Iraq. The Common Remote Operated Weapons System, CROWS, add-on kit allows for the mounting of an M2A 1.50 caliber machine gun, M240, or M249 SAW on a remote weapons platform. Some current versions of the Tank Urban Survival Kit, TUSK, on the M1A2 have replaced this with transparent gun shields on the commander's weapon station. The M1A1 Abrams Integrated Management, AIM, upgrade variant equips the .50 caliber gun with a thermal sight for accurate shooting in low visibility conditions. 2. A 7.62mm M240 machine gun is mounted on a skate mount in front of the loader's hatch. During the Iraq War, some of these guns were fitted with gun shields and night vision scopes for low visibility engagements. This gun can be moved to the tank commander's position if the M2 50 calories is damaged. 3. Another 7.62mm M240 machine gun is installed in a coaxial mount to the right of the main gun, allowing it to target the same objectives as the primary weapon. The coaxial machine gun is aimed and fired using the same computerized firing control system as the main gun. Earlier M1 and M1A1 models carry 3,000 rounds of linked ammunition ready to fire, while later models have slightly reduced ammunition capacity to accommodate new system electronics. A typical 7.62mm combat loadout ranges from 10,000 to 14,000 rounds per tank. 4. As an optional addition, a second coaxial 50 calories. 12.7mm, M2 HB machine gun can be mounted directly above the main gun in a remote weapons platform, as part of the Counter-Sniper Anti-Material Mount (CHOM) package. The Abrams tank is equipped with an advanced ballistic fire control computer that processes data from various sources to accurately fire the main gun. The computer calculates and displays 3 essential components of a ballistic solution: lead angle, ammunition type, and range to the target. To determine these components, the system uses input from a laser rangefinder, crosswind sensor, pendulum static cant sensor, round-specific performance data, tank-specific bore sight alignment data, ammunition temperature, air temperature, barometric pressure, a muzzle reference system, misses, that compensates for barrel drop and heating, and target speed from tracking rate tachometers in the gunner's or commander's controls handles. The ballistic computer processes these factors and updates the solution 30 times per second, displaying the updated information as a reticle in the gunner's or tank commander's field of view in both day and thermal modes. By manipulating the turret and a complex mirror arrangement, the computer ensures that the gunner only needs to keep the reticle on the target and fire to achieve a hit. The computer automatically applies the proper lead and gun tube elevation to the turret, greatly simplifying the gunner's task. The M1 and M1A1 Abrams variants use the Computing Devices Canada Ballistic Computer System for fire control, while the M1A2 employs the Fire Control Electronics Unit manufactured by GDLS. The laser designator is a Hughes model. The Abrams fire control system uses the computed data to generate a firing solution for the gunner, resulting in a hit percentage exceeding 95% at nominal ranges. Both the commander and the gunner have the ability to fire the main gun. The commander's independent thermal viewer, CITV, on the M1A2 allows the commander to locate targets and pass them on to the gunner for engagement while simultaneously scanning for new targets. In the event of a malfunction or damage to the primary sight system, the main and coaxial weapons can be manually aimed using the gunner's auxiliary sight, GAS, a telescopic scope bore-sighted to the main gun. The GAS features 2 interchangeable reticles, one for heat and multi-purpose anti-tank, MPAT, ammunition, and another for APST and Smart Target Activated Fire and Forget, STAF, ammunition. If the fire control or hydraulic systems fail, turret traverse and main gun elevation can still be performed using manual handles and cranks. The commander's M2HB.50 caliber machine gun on the M1 and M1A1 is aimed using a 3x magnification sight integrated into the commander's weapon station, CWS. On the M1A2, the machine gun's iron sights or a remote aiming system, such as the common remotely operated weapon station, CROWS, when used with the tank urban survival kit, are utilized. The loader's M240 machine gun is aimed using either the built-in iron sights or a thermal scope mounted on the gun. In late 2017, the U.S. Marine Corps planned to upgrade their 400 M1A1 Abrams tanks with the Abrams Integrated Display and Targeting System, ADATS. This upgrade replaces the black and white camera view with a color sight and day/night thermal sight, simplifies handling with a single set of controls, and includes a slew to Q button that repositions the turret with a single command. Initial testing demonstrated that these upgrades reduce target engagement time from 6 seconds to 3 by enhancing collaboration between the commander and gunner on target acquisition. Mobility. The M1 Abrams is powered by an AGT 1500 multi-fuel gas turbine engine, originally manufactured by Lycoming and now by Honeywell. The engine is capable of producing 1,500 shaft horsepower at 30,000 revolutions per minute and 395 pounds-foot of torque at 10,000 revolutions per minute. It is paired with a 6-speed, 4 forward, 2 reverse, Allison X1100 3B hydrokinetic automatic transmission, allowing the tank to reach a governed top speed of 45 miles per hour on paved roads and 30 miles per hour cross-country. With the governor removed, speeds of around 60 miles per hour are possible on improved surfaces, but this can lead to drivetrain damage and increased crew injury risk. The Abrams was designed around this engine, which is multi-fuel capable and can run on diesel, gasoline, marine diesel, and jet fuel such as JP4 or JP8. By 1989, the Army was transitioning to JP8 to reduce logistics burden, but as of 2023, diesel is still frequently used. Australian M1A1 AIMSA tanks burn diesel fuel due to the lower prevalence of JP8 in the Australian Army. While the gas turbine propulsion system has proven reliable in practice and combat, its high fuel consumption poses a significant logistical challenge. The engine consumes more than 1.67 US gallons per mile, 60 US gallons per hour, when traveling cross-country and 10 US gallons per hour when idle. However, the turbine is notably quiet compared to diesel engines of similar power output, earning the Abrams the nickname Whispering Death during its 1982 Reforger exercise debut. In 2000, the Army selected the Honeywell LV-105 gas turbine engine for the Common Engine program, which aimed to provide a new engine for the Abrams and the XM2001 Crusader. The LV-105 offered improvements in weight, size, acceleration, noise, and fuel consumption, but the program was shelved when the Crusader was cancelled. From 1991 to 1994, the Army fitted 1,500 Abrams turrets with external auxiliary power units, APUs, to allow some functions to run without the main engine. An Under Armour APU was chosen for the M1A2 SEP variant but proved unreliable and was replaced with a battery-based alternate APU starting in 2005. Although not designed for carrying riders, the Abrams can transport troops in tank descent by switching off the turret stabilization device. A battle-equipped infantry squad can ride on the rear of the tank, using ropes, equipment straps, and snap links for security. The Abrams features permanently bonded rubber track pads, T156, which save weight but are less desirable in snow as they cannot be replaced with grousers. Track wear is a significant consumable expense for the U.S. Army. In 1988, FMC Corporation was awarded a contract for T158 tracks with replaceable pads, rated for about double the life of the previous shoe but weighing 3,000 pounds more. The driver is equipped with a thermal viewer, which on at least some models is the Hewson/VAS-3. The M1 Abrams possesses strategic mobility, allowing the tanks to be deployed in a timely, cost-effective, and synchronized manner. The tank can be transported by the C-5 Galaxy or C-17 Globemaster III aircraft, although their capacity is limited to 2 combat-ready tanks in a C-5 and 1 in a C-17. This limited capacity caused logistical challenges during the deployment for the First Gulf War, but there was sufficient time to transport 1,848 tanks by ship. The United States Marine Corps transports their Abrams tanks by combat ship, with a Wasp-class landing helicopter dock, LHD, typically carrying a platoon of 4 to 5 tanks attached to the deployed Marine Expeditionary Unit. These tanks are then amphibiously transported to shore by Landing Craft Air Cushion, LCAC, with 1 combat-ready tank per landing craft. The Abrams can also be transported by truck, specifically the Oshkosh M1070 and M1000 Heavy Equipment Transporter System, HETS, for the U.S. military. The HETS is capable of operating on highways, secondary roads, and cross-country, and can accommodate the 4 tank crew members. The Australian Army uses customized manned trucks to transport their Abrams tanks. The first instance of the Abrams being airlifted directly into a battlefield occurred in October 1993, following the Battle of Mogadishu. 18 M1 tanks were transported by C-5 aircraft from Hunter Army Airfield, Georgia, to Somalia. Crew. The introduction of the M1 Abrams into U.S. Army service in 1980 brought about an organizational change in the standard tank platoon, reducing it from 5 tanks to 4. This change was influenced by the improved capabilities of the new tank and its higher cost. The reduction in platoon size required adaptations in tactics, focusing on platoon and section actions where the platoon leader had to both operate their tank and manage the unit. As of 2019, the tank platoon organization within the U.S. Army and U.S. Marine Corps consists of 4 Abrams MBTs divided into 2 sections, with 2 tanks in each section. A section includes the platoon leader, or platoon commander in USMC terminology, who commands Tank 1, and their wingman, who commands Tank 2. B section comprises the platoon sergeant, who is the tank commander of Tank 4, and Tank 3, which is the platoon sergeant's wingman. The wingman concept dictates that individual tanks orient off the tank to their left or right side. In the tank platoon, Tank 2 orients off the platoon leader's tank, while Tank 3 orients off the platoon sergeant's tank. The platoon sergeant, in turn, orients off the platoon leader's tank. The tank platoon is an integral part of armor companies within a combined arms battalion. The platoon may be attached to various organizations, commonly a mechanized infantry company, to form company teams. It may also be placed under the control of an infantry organization, with the level of control determined by the command relationship established by its higher headquarters. An armor company is organized, equipped, and trained to fight either pure or as a task-organized company team. The company includes a headquarters and 3 tank platoons. The company headquarters is equipped with 2 MBTs, armored personnel carriers, and wheeled vehicles for mission command and control and sustainment. Thanks for watching, The Animated General. Out.